Hello, I'm Liam Wright, and today I'm going to be using LLMs within the Positron IDE to perform an analysis where I'm going to take crime data at the community safety partnership level and convert that into a map or display it as a map. I'm not a geographer, so this is something relatively new to me, and I wanted to do this as inspiration to show you that with LLMs you can do some interesting analyses very quickly. Now, I've already downloaded the data on crime rates from the ONS website. There's a sheet within it called Table C5 that contains the per capita crime rates. So we have individual rows for the different community safety partnerships, and then in the I column we have the per capita total recorded crime rate. That is data that I've downloaded, and I've got it in this folder that I have open within Positron. I've also downloaded some data from the Ordnance Survey website that gives shape files, which are boundaries for the different community safety partnerships. To open up, we're going to be using Claude, which has a really useful integration within Positron. We'll have information at the end of the blog post showing you how to set it up and a link to the Positron website talking more about that. But here I'm just going to click this robot icon, which brings up a sidebar which has the general sort of chat interface that you might expect from an LLM. Now, the Claude Positron Assistant has three different modes. We have Agent, which we're not going to use, and we also have Ask and Edit. Ask is the usual sort of interaction way where you ask a question, you get an answer, and I'll type the question into this box and we'll get the answer on the left-hand side. You'll see at the minute I've just opened a new session of R, so nothing's loaded into memory. There's been no output so far or anything like that. Let me just resize my screen slightly. So I've already written some prompts just to make this a bit simpler. So first we're just going to ask, I have data on crime rates in England and Wales at the Community Safety Partnership level in a file called crimerates.xlsx. So that's an Excel spreadsheet within the sheet Table C5. I want to plot these data as a map in R. The boundaries are in a shapefile called cspboundaries.shp. First, give me code to import the spreadsheet into R. I've given it the variable names, which start in row 8. So just to show, we had variable names in row 8. And then the CSP codes, because we have human readable names in column D, but the codes that we'll use for merging are in column C. And the crime rates are in column I, which we discussed already. I'm also saying that some rows have missing data and need to be dropped. The variable name should be renamed to something sensible because we don't want to read in the data set into R and then have a variable name called Community Safety Partnership Code, because that's not going to be easy to work with later. So I'll just send that now. So it gives me back a response relatively quickly. If we hover over a box of code, it's got various different buttons. We can run the code using the play button. We can add it into our editor, so into this open file using this button. We can insert it at a cursor with this, copy it, and so on. I'm just going to add it in here using the third button, and then we'll just load this data. So I'm not going to read it in detail, but basically we'll be able to see whether it worked or not in a second. So that's just running. Okay, so we got an error. It said sheet 9 has 32 columns, but col types has length 4. So I'm just going to send that error back into a Positron Assistant to Claude to get it to change the code. So I'll just delete that code that we have already. Okay, let's try again. So there, that's worked now. So we've got CSP code, CSP name, and the crime rate. Okay, so that's what we wanted. So the next prompt I'm going to give, I'm just going to ask, now give me the code to read in the shapefile, which is the file that contains the boundaries, and draw a map so I can see the boundaries are as expected. So we're going to get a plot that just has an outline of England and Wales, hopefully, if this has worked correctly. So let's just scroll down the file here. Okay, it gives me some information on the code. I'm not going to read that. I just want to insert the code here and get get things running. So it's going to load two packages, ggplot2, which creates maps, or creates plots rather, and SF, which is what you use for working with geographic data. So let's run that code. Okay, so I'm just going to open this in a new window. So you can see that it's given us the outline of England and Wales, so we know that it's probably read in the data correctly. Okay, now I'm going to say another prompt, which is give me the code to merge the crime rates data with the shapefile data and plot the crime rates on the map, check the merges have been performed correctly. So I'm just going to enter that now. Okay, you can see this is running very fast. Notice also that it says the shapefile has a column CSP23CD that should match with your CSP code column. So I didn't tell it anything about the shapefile, the name of the columns or anything like that, but it's worked out that because behind the scenes, positron is sending information from my current session to the API calls to Claude, so it's giving us information about it's sending information about the metadata for the various objects. So it's been able to work out what the relevant columns should be without me explicitly declaring them. Okay, so let me run that now. Here we go. So let's see that in a new window again. So we now have this nice plot which has got the crime rates on it. You can see that they're coloured by the level of crime. A light yellow is a crime rate of 400, a dark purple is a crime rate of towards 0, I guess. Notice here that there's very few points that actually have these lighter colours. Presumably this is because there's a very skewed distribution, so we might want to use Claude to change this plot so that we can see better distinguish between community safety partnership areas based on their crime rates. So I'm just going to add another prompt, just saying that the distribution of crime rates is skewed, so make appropriate adjustments to the visualization. Okay, so it's just going to give me a histogram to check the distribution, and then it's also going to, in this case, I think just plot quantile breaks instead. So again, we're just going to put this code into the file so we can use it later or store it for later if we want to. So let's just make this first plot. So you'll see that we have this distribution of crime rates which is skewed. I'll just go back to that, but there's also, it appears, this huge outlier here. So it might make sense to remake the plot without that outlier included. And now we've got this different plot here that is accounted for the skewness, but again, that's not worked very well. I think what it's done is just use a different scale, maybe a log scale or something like that. So let's give it one other prompt. What I think this will be our penultimate prompt. There appears to be outliers, remove crime rate outliers and create new visualization. Just make that a bit smaller. So looking at your data, I can see from the summary, so let's wait for that to finish. Excuse me. Okay, this might take a few seconds because it seems to be quite a long bit of code. Okay, so at the top of the response it said, looking at your data, I can see the summary that there are potential outliers with a maximum of 446.41 compared to a mean of 81. So it's going to remove outliers using the interquartile method to create a cleaner visualization. So notice here that we had this plot that gave us this outlier. I think maybe there was another bit of, there was also this output as well that said that the maximum is 446.41. So again, this information, what's in the console, what's in our metadata from the objects is being sent to Claude, and it's really allowed us to integrate LLMs into our workflow so we can work really fast. So now let me just try and run this code instead. I'm just going to again add it to the end of the file. And so firstly it's just telling me some stuff about how many outliers are removed. So I think this is the upper bound without the outliers. It seems like there's 5 outliers that have been removed. That includes Westminster, which is this one with this huge high crime rate, but then there's also Camden, Manchester, Kensington and Chelsea and Middlesbrough. So it's just going to create a data frame that removes the outliers, I think, and then it's going to plot them again. So let's do this. Okay, there we go. So let's look at this now. So now we can see that the outliers have been removed. The top of the crime rate on this graph is about 150. There's much more distinction between the different areas. And it also says at the bottom, grey areas indicate missing data or outliers. So we now have a better visualization that's able to give us a sense of differences between regions or community safety partnership areas rather, by removing the outliers that were making the plot not very good. Okay, so there's one other prompt I could do, which is suggest some other analyses that I could perform with this data and give me the code to do so. I'm just going to put that into the chatbot now, so you can see it's given us the code for spatial autocorrelation analysis. I imagine it's also going to give us different types of analysis as well, some simple descriptives. I'm not going to run those right now because I think that'll take too long, but you can see how quickly we're able to make a very usable plot using data that you might not have had much experience with. I certainly don't have much experience with geographic data, so it's really LLMs are really incredible in enhancing our abilities very fast, but obviously we need to make sure that we are critical and know that what we're doing as we use them. Thank you.